We are going to continue with our learning target 20, which is I can use numbers written in scientific notation to express how many times as much one is than the other. So to find out how many times greater something is, we are going to divide the larger value by the smaller value. And we're going to identify which is larger or smaller using our comparing method that we talked about in our previous video. So our first question says, how many times greater is Jupiter than Earth? So if I look at my examples here, I see that my Jupiter has an exponent of 27, my Earth mass has an exponent of 24. That means that my Jupiter is going to be the larger or the greater value, and Earth is going to be the smaller value. Let's just change greater to larger. So to find out how many times larger Jupiter is than Earth, I am going to take the value of the larger planet, 1.89 times 10 to the 27th, and I'm going to divide it by Earth's mass, 5.97 times 10 to the 24th. So the first thing that I'm going to look at is I'm going to be dividing my coefficients or my significant digits. So this 1.89 divided by 5.97. 1.89 is close to 2, 5.97 is close to 6. So if I were to divide 2 by 6, that gives me 1/3, which is approximately 0.33333. However, if I type my values in exactly, we get that 1.08 or 1.89 divided by 5.97 is 0.31, and we'll round to the nearest thousandths, so 7. I'm going to keep my multiplying by 10, and then I'm going to use my exponent rules to simplify 10 to the 27th divided by 10 to the 24th. Since I'm dividing, I'm going to be using the quotient rule. And the quotient rule tells me that I'm going to subtract my exponents of a common base when I'm dividing those common bases. So 27 minus 24 is 3. Now, one thing I notice is that this value right here is not written in scientific notation. Our first significant digits need to be between 1 and 10. So to convert this to scientific notation, I have to move the decimal one place to the right. And according to our acronym LARS, left add, right subtract, since I'm moving my decimal one place to the right, I need to subtract 1 from my exponent. So that gives me 3.17 times 10 to the second power. Now, to answer the question of how many times greater, yes, I have the value in scientific notation, but that doesn't always mean the same thing to everyone. So we're going to place it into standard form. So to do that, I'm going to take my decimal and I'm going to move it 2 places to the right. 1, 2. So that means that Jupiter is about 317 times the size of Earth. If I look at number 2, how many times bigger is Neptune than Mars? I'm going to look at my exponents in each of my mass sizes. Neptune has an exponent of 26. Mars has an exponent of 23. So Neptune is the larger planet, and Mars is the smaller planet. So to set this up, I'm going to divide the mass of Neptune by the mass of Mars. So again, first thing I'm going to do is divide those coefficients, those significant digits, and 1.02 divided by 6.42 is equal to 0.15, rounding to the nearest thousandth, it would be 9, times, and then following my quotient rule, 26 take away 23, that would give me 10 to the third power. So to convert this to scientific notation, I need to move my decimal one place to the right. According to my acronym LARS, left add, right subtract. Since I'm moving one decimal place to the right, I'm going to subtract 1, which gives me 1.59 times 10 to the second power. If I convert that to standard form, I'm going to move my decimal to the right 2 places. 1, 2. So Neptune is approximately 159 times as great as Mars, or 159 times bigger than Mars.